These are the patterns of invisible waves we use today for communications. Radio waves, television waves, microwaves. In the same family, of vast potential for tomorrow, are visible waves, the waves which man calls light. In other centuries, they would have called it magic. Voice by waves, pictures by waves, machines that talk to other machines by waves. There is still a quality of magic in it, this manipulation of invisible waves by which man relays messages across vast distances, by which he controls and guides waves, amplifies them to extend the limits of communications. For almost a century, scientists have been challenged by the knowledge that light waves are like radio waves, but are visible. But science knew no way of generating and controlling light waves as it controls the radio waves with which we are more familiar. Today, research scientists in many areas are experimenting with light. In the communications industry, there is special interest in a special kind of light wave, known as coherent light. Coherent light, the scientists know, can be precisely directed, amplified, and controlled. And theoretically, a system using coherent light could provide a communications highway of staggering capacity, a potential capacity of more than 1 million telephone conversations or 1,000 television channels. Man has long since generated light for vision, but this ordinary light by which we see is wayward, undisciplined, a jumble of waves of different sizes and colors radiating outwards in wild disorder. How can light, in nature undisciplined, be harnessed for communications, which needs a constant coherent flow of light in only one direction? At Bell Telephone Laboratories, day by day, scientists have under development a new device which could revolutionize man's use of light. It is called a laser, or sometimes an optical maser. The light it generates is a kind of light never before known on Earth. It flows in a narrow beam, as nearly parallel as nature allows, a constant stream of precisely controlled light, coherent light. There are many types of lasers. A laser may be a large glass tube specially formed to hold helium, neon, or other gases. It may be a liquid, glass, or plastic. Or the heart of the laser may be a tiny crystal made to precise specifications. Inside this laser, equipped with special mirrors, atoms are excited with an external light source. When they are weakly excited, the atoms begin to give off light independently of one another. However, when they are strongly excited, conditions are created which force the atoms to release light all to the same beam. The beam gets brighter as it moves within the laser. In a fraction of a second, it builds up millions of times and bursts through one of the mirrors. A beam of light more intense and more precisely directed than has ever been produced in man's history. In 1958, ideas basic to the laser were presented in a paper from Bell Laboratories by Drs. Shollow and Towns. In 1960, at various research centers, the first lasers were actually built. They were pulse lasers and could emit only short but concentrated bursts of light energy. A pulse of energy that could be made to pierce a hole in a steel blade. But the need of communications normally is not for short bursts of energy. So, work at Bell Laboratories went forward in the search for a laser that could send out a continuous beam of coherent light. The scientists who built this laser, who coaxed it to give forth light, gave it a name. They called it Eve. February 1961. The first continuous coherent light on Earth. Today, man can produce in many variations a kind of light totally new to his experience. A light which begins in waves so nearly parallel that its rays hardly diverge at all, no matter how great the distance. A light more purely one color than any light we have known before. A light 10 million times brighter than the light on the surface of the sun. The scientist is an explorer, moving day by day from the known to the unknown. And, like the explorer, he may have hopes which he prefers to leave unspoken. Yet in this light, which moves in patterns whose implications are not yet grasped, even cautious science sees a giant step forward in man's conquest of light and of his universe. For in the laser's light are endless possibilities, another means of illuminating the age-old secrets of the human cell, another pathway to research in the spinning worlds of atomic structure, an ingenious microscopic welding torch, a delicate tool for surgery. Tomorrow, light may be a major medium over which men communicate, a possible answer to the ever-growing need for channels of communication. Science itself cannot know the total promise, for it stands now only at the threshold of its exploration. Yet, this narrow pathway of light leads surely to tomorrow. Because it spreads so little, it may help man to map the moon. Projected toward the shadowed valleys, a 250,000 miles away, a laser beam can be focused on a tiny area only a few hundred yards wide. A bridge of light, a bridge across which man may communicate on Earth and in the endless reaches of outer space. The laser, a dramatic achievement in the conquest of light.